Boom. All right, here we go. So today we are going to be applying proportional reasoning on page 9 of Agile Mind in the computer. In our workbook, which we should have out right now, we're going to be on page 39. All right, so everybody should have their workbook turned to page 39. And we're going to be in block 10, okay? And in this block, what our main objective and goal is today is we're going to be applying proportional reasoning in a statistical sampling context. So to get started with class today, our opening question is, if we were to have a bowl and it was filled with marbles, okay? And in this bowl filled with marbles, there are a certain number of red marbles. And we're going to make 20 pools to get out marbles. And every time we pull out these marbles, we tally the results we get. When we do this, is there any way that we could predict how many red marbles are in the bowl? Is there a way we could determine that or predict about how many would be in that bowl? What could we do?
Can you repeat that?
Yeah. All
My
right.
internet went out.
So we are going to have 200 objects in a bowl. The 200 objects that are going to be there are marbles. All right. And there's some red marbles, some blue marbles, and some yellow marbles. All right. We're going to take 20 pools. All right. So we're going to put our hand in there and pull out some marbles. And every time we do, we're going to tally the results. And tally means to take, like an actual measurement of the results that we get. Okay. And we're going to write them down. After we do that, is there a way that we could predict how many red marbles are in that bowl? What do y'all think? Yes or no?
Yes.
All right. I agree. We can get pretty close with an estimate. How could we do it? What could we do? What could we do with those 20 pools so that we could try to figure out about how many red are in there? What could we get? Tamarian, what do you think?
This is a question. What page are we on again?
Oh, we're on page 39 in our workbook. So I'm going to leave that question with you, and I want you to think about that question as we do our actual assignment today. And at the end of the class, I'm going to restate this question, and I want to see if we can figure out if we would be able to estimate about how many red are in that bowl. Okay? So that's going to be the question that we actually end class with. All right? So make sure you keep that on your mind. So we're going to get started today by reading our first page that is dealing with sea lice. All right? This is a very disgusting creature, and we're going to find out about them today. So, if you would, Miss Angel, would you read this for us, please? Angel V. Go ahead, Angel.
Sea lice are small
Crustaceans?
crustaceans that can act as parasites for
Uh-oh, you muted yourself.
acts as a parasite for many types of salmon. Sea lice are a major problem for the salmon farming
Industry?
industry. They can result in huge losses for a farm, but you can use proportional reasoning to estimate how many sick and healthy fish are in the pond. Use the animation to investigate.
Thank you. All right, so we're going to take this and we're going to figure out about these sea lice and figure out how many healthy fish we have and how many sick fish that we have. So we're going to start with this. So it says you work for a salmon fish farm. You estimate that you have approximately 285 salmon in your large pond. Use the net to sample fish and check out how many have sea lice. So remember the word sample, that is basically focusing on when you take a small amount of something, okay? So, for instance, whenever you go through the grocery store and you taste test something, we don't get to do that now, but we used to could go through the grocery store and they would like let you taste something. That's a sample, all right? Because you're taking just a small amount and seeing what it tastes like, all right? So, the same thing is applying to this. We're going to take a small sample of the fish and try to determine how many are sick based off of one small sample. All right, so we're going to use our net and she's going to go fishing. So when she catches her fish, how many fish did she catch that had lice?
3.
3. And how many total fish did she catch in all?
14.
All right. So how could we determine how many healthy fish there are?
Subtracting?
Yeah. We could do 14 minus 3 and then tell us how many healthy fish there are. All right. So based off of this, we need to figure out about how many fish have sea lice based off of the information we just found. We know that 3 out of 14 have sea lice. So we need to figure out about how many have lice out of 285. All right. So it says compare the number of fish with sea lice in your sample to the total number of fish in the sample. How can you use this information to estimate the number of fish with sea lice in the entire pond? So what do we need to do? What do we need to find?
Maybe the scale factor?
You are 100% correct. All right, so let's take a look at our next slide. So they've set this up. They have their fish with sea lice over the amount of fish that are netted in the sample. And so they've set that equal to X over 285. And so to determine X, we're going to find our scale factor, just like Kalia said. And so to do that, they're taking 285 and dividing it by 14. So when they do that, we find the scale factor. So what do we need to do with the scale factor to determine what X is?
Multiply it by 3.
That's right. We're going to multiply it by 3. That's 100% correct. All right, so we're taking 20.4 and we're going to multiply it by 3, and that's going to tell us about how many fish have sea lice. About how many have them?
61.2.
Yes,
61.2.
that is correct. Good job. So, does everybody in here see how they were able to find that?
Yes. Yes, sir.
All right. Do you think that one sample is enough to estimate the number of fish with sea lice in the entire pond?
Yes, sir.
All right. So we're going to see if it makes a difference if we get a good number of samples so that we can get an average and see if this estimate is close to the amount that we find after doing 5 samples, okay? So everybody's going to be on page 39 in their workbook, and we are going to write down each trial that we have. All right, so look at what this says. Braden, will you read that for us, please?
Sir?
Will you read what I have highlighted, please?
Sorry, my stuff was lagging. One sample may be representative of the entire pond. To make a better estimate, you need to sample more of the pond. Use the net 5 times to get 5 separate samples. For each sample, calculate and estimate the entire pond. You can show graph button to see a graph of the data you are collecting.
All right, good deal. So, thinking back about what I asked a while ago, is one enough? I don't know if you've ever been fishing or not, but when you go fishing, there's a different amount of fish everywhere that you're at, okay? Like in one spot, you might fish for like an hour and not catch anything. And then you go to a different spot in the pond and you might catch 4 or 5 fish. So that can be the same thing that happens when this woman's dipping this net down in here to get these fish. All right? She might not be in a good spot. So that's why we're going to take 5 representations, all right, or 5 samples. Does that make sense to everybody? Hopefully. All right. So let's use this net and see what she catches. All right. So in this one, she captured 3 with lice, and there were 17 in total. So what we're going to do is we're going to take this amount and we're going to set it up exactly like they did. So I'm going to take this dark blue and I'm going to write right here, but I got 3 over 17, and I'm going to set it equal to x over 285. And I want to find the scale factor like Kalia said a while ago. So I need to do 285 divided by the total amount of fish we just caught, which was 17. All right, so we're going to take our calculator and we're going to do 285 divided by 17. And when we do that, we get this extravagant number. So if you look at this, we got 16.764705882. I want to round to the nearest tenth. All right. So with that being said, I want to round to this number. So we're going to look in the hundredths place. If the hundredths place is 5 or more, that means that the 10th place goes up. If it is 4 or less, then the 10th place stays the same. So in this case, what will be our new amount?
16.8.
Good job. So we get 16.8 for our what?
Scale factor.
Great job. So we're going to take our scale factor, and what do we do with it? To determine the number of the number of sick fish. I got to do 16.8. Remember, scale factor is a number that
Will it be times 3?
Good job. We're going to multiply it by 3 because the scale factor is the number that we use to enlarge or reduce our original figure. Okay? So when we do 16.8 times 3, that's not right. Let's try it again. I must have added 16.8 times 3 gives us what? 50.4. That's right. All right. So we should have every bit of this information right here, along with 50.4, written down on page 39 on our trial 1. Everybody should have that written down. So if you don't, I'm going to give you about 5 seconds to get that written down.
On trial 1 or trial 2, because it says for trial 1, 317. So what we do it for?
Yeah, so trial 1, you should have 3 to 17. All right. We're going to get rid of this. We're going to keep on moving. Let's try our next one. First, we got to put our answer in there. Well, that wasn't supposed to happen. I'll fix that in a second. So we're going to say 50.4. And we're going to check our answer, make sure we got it right. All right, so did they work that problem the same way that we did?
Yes.
Yeah, they did. So we're going to keep moving and see if we find something different on the next one. So we're going to let her go do some fishing again. All right, so once again, she caught 3 of them that were sick. But this time she only caught how many?
12 total fish.
Correct. So we're going to take this and we are going to do the same as we just did. All right, so what do I need to do to set it up?
Is it 3 over 12? And then the denominator of the next fraction would be 285 with like an x.
Good job. Remember that X is just a letter that stands for an unknown number. And so this X right here is actually called a variable. All right? And a variable is a letter that is in place of an unknown number or a number that we do not know yet. All right? So what would we do to find our answer? What do we need to do?
Multiply scale factor times 3.
Yeah, but right now we don't have our scale factor, right?
Oh, we find a new scale factor?
Correct. So we got to find our scale factor by doing 285 divided by what?
12.
Good. So we're going to find our new scale factor. So we'll take our calculator once again. So we got 285 divided by 12. And so we got 23.75. So what's that going to be rounded to the nearest 10th?
23.7. 23.8.
All right. So we got 2 different answers there. So let's discuss it.
I didn't round it.
All right. So remember that when we round, that if we're rounding to the nearest 10th, we're going to look at the hundredths place. And if the hundredths place is 5 or more, then the tenths place goes up how many times?
1 time.
1 time. So 23.75 rounded to the nearest hundredth is going to be what? I mean, not the nearest hundredth, to the nearest tenth is going to be what?
23.8.
Perfect. All right. So we're going to take that. And that 23.8 is our what now, class?
Scale factor?
Correct. That's our scale factor. And so what do we need to do with our scale factor so that we can determine the amount of sick fish?
Multiply it by 3.
Correct. So we're going to take 23.8. We're going to multiply it by 3. And what do we get?
71.4.
All right. So we're going to write that down for trial 2. So make sure that everybody is writing your work down on page 39 in trial 2. So this time we got an estimate of 71.4 that would have sea lice, okay? So we're going to put that amount in. We're going to check our work, make sure we get the same answer as they do. All right, does that look the same as what we just did?
Yes.
Yeah, it does. Make sure you give me a thumbs up and let me know that you're following with me, okay? All right, so once again, we're going to take this, we're going to use our net, and we're going to let this lady go do some more fishing for us. So let's see what she gets on this third run. All right, Kyron, what'd she get this time?
Hold on, what was the question again? I was too busy trying to put the thumbs up.
All right, I got you. So what'd she get for trial 3 for our sick fish? How many sick fish do we have? How many fish have lice?
3.
3 of them. Is this the same as this?
Yes.
Yes. Do we need to go through all that work again?
No, sir.
No, because it's got to be what?
3 and 12. Wait, no. Wait.
What's our estimate going to be? Help him out.
Yeah, I don't know.
Somebody help him out. What would our estimate be?
71.4.
Why is it 71.4, Levi?
Because it's the same as this trial 2.
Correct. All right, so we're going to put that answer in there. It'll be the same. That worked out good. Hagen, is that what you were going to say? All right, so we got this. We got 3 times 23.8, just like we did just a second ago. And they got 71.4 again. So basically, everything that we wrote in trial 2, we're going to write in trial 3. Or you could put the same and then put our estimate of 71.4. All right, so let's let our lady go fishing again for trial 4. All right, so looking at this, is this similar to any of the trials that we've already had?
Yes, it's similar to trial 1.
That's correct. Good deal. So what do we need to do? What could we do?
Write what we had.
Yeah, that's all we got to do is write down what we had. So we had 50.4 for the first one. All right, so we're going to check our work. They got 16.8 for that scale factor, and they multiplied it by the amount of fish that were sick, and they got 50.4 again. All right, so let's see what happens on trial 5. Hopefully we'll get a new number. Let's see what happens. Oh, yeah, we got something different this time. All right, so what did we get for the amount of sick fish?
2.
2, good. And how many did they catch in all that time?
15.
Good. So what can we do to set it up this time?
We would do 2 over 15, and then the next fraction denominator will be 285 with the x, because we don't know what the scale factor will be.
Good deal. All right. And so to find our scale factor, what would we do?
Divide 15 by 285.
Great job. So we got 285 divided by 15. And this is going to give us our scale factor. So we're going to take our calculator and we're going to do 285. Let me move that over here. We're going to do 285 divided by 15. What are we going to get?
19.
All right. And what do we need to do with our scale factor so that we can determine what x is?
Multiply it.
So what am I multiplying?
19 times 2.
Good. And what is 19 times 2?
38.
All right, so let's check our work. We're going to put that in here. Let's see if they get the same answer as we did. Did they get what we did?
Yes.
All right, so we're going to look at their graph, and this.
I can't see.
Okay. What do you see?
A girl fishing.
That's what you're supposed to see right now.
Okay.
All right, so really what you're focusing on is this right here. Can you see what I just circled? All right, good. All right,
Yes.
all right. So let's take a look at this. Angel Stewart, out of all of these that we got, we had 50.4, 71.4, 71.4, and 50.4, and 38. How would we be able to figure out about how many fish out of 285 have sea lice? What could I do with these amounts?
Add them.
Okay, we could add them up, and then what would we need to do? If I was trying to find out about how many are sick, what could I do?
Add the sick fish.
All right, we could add them up and then get a what?
Scale factor.
Not a scale factor. We're actually going to say we could get an average. I know we haven't talked about getting averages any, but we could get an average out of the total amount that we were given, and then that would tell us a closer amount of about how many are what? What are we talking about? How many fish have what?
Please.
Sea lice. All right.
Sea lice.
Good. So, once again, just like someone said just a second ago, they said we could add them up. The only difference would be we would add all of those 5 together. We would divide it by 5, and that would give us the average. They didn't ask us to do that here, but that's what we could do to find a closer amount. Now, let's take a look at this graph, or a better estimate. So, looking at their graph, you'll notice that when we had 2 fish that had sea lice, that was out of 15 fish. So they went to 2 and then up to 15. Then we had 3 that had sea lice, and so we went from 3 up to 12, which was our total. That happened 2 times. All right. And then we had 3 that got sick with sea lice, but we caught those, or she caught those, with a total of 17 fish. And once again, that happened 2 times. So it says, based on your 5 trials, how many fish in the pond do you think have sea lice? You'll need to think back across all of the estimates that we calculated. All right, so let's take that calculator and let's see what we can come up with. Let me clear this off of here. All right, so the first one that we had what? What was our estimate here? For trial 1. Trial 1, 71.4. And we had 2 of those. What do we have for trial 2?
50.4.
Good. Did we have that twice?
Yes.
Yep. And then our last one for trial 5, what was our estimate?
38.
All right. So we're going to figure out the total. So the total is 281.6. But there were how many trials?
5.
So to get the average, what do I need to do?
Divide 281.6 by 5.
Good job. And what are we going to get? About how many?
56.3.
All right. So about 56 fish in her pond have what?
Sea lice.
Sea lice. That's gross. All right. So we did a great job there. All right. So we're going to take this information, and right now I'm going to allow you to graph this in your own graph. Now, while you're working on your graph, I'm going to pull up my graph at the same time. So I'm going to pull up my activity sheets. All right. And so when you're looking at our graph, you'll notice that ours is bare. It doesn't have anything there, does it? So what do we need to do to our graph?
Label it.
Yeah, let's label it. So if we're going from left to right, our horizontal axis is our x-axis. Our vertical axis is our what?
Y-axis.
Our y-axis. All right. In this case, our y is going to be the total number of fish. All right. And our x would be our fish with what?
Sea lice.
All right. So I'm going to try to write that down here for us. Sorry on that handwriting. So that says sea lice. So now what we need to do is we need to write our numbers all the way across the bottom and our numbers across the top. So how many had sea lice? The largest number that had sea lice was what?
3.
3. So I'm going to go 1, 2, 3. I'm not going to finish this right now just to save us some time because we don't need to go past 3. All right. And over here, what was the largest amount of fish that she caught with her net?
17.
All right. So I'm going to count by what's a good thing that we could count by? What's a good number we could count by since there's not 17 of these up here?
2.
All right. So let's count by 2. So I got 2, 4, 6, 8, 10, 12, 14, 16, and 18. We could keep going, but I'm not going to do that so that I can save time with us right now. All right, so the first one that we found had how many sea lice in our first trial?
3.
Good. We had 3. So I'm going to go on my X, 1, 2, 3. So I'm 3 to the right. And then out of how many fish did she catch?
17.
Okay, so 17 isn't on here, so I need to go a little bit between what two numbers?
16 and 18.
All right, and I'm going to go dead center. All right. All right. So now let's look at our next one. What was our next one?
3 to 13.
Okay, so we're going to go 3, and then we're going to go up to 13. Did we get a 3 to 13?
3 to 14.
Yeah, 3 to 14. All right. And then what was our next one?
3 to 12.
Okay. So so I'm going to go 3 to 12. I think the 3 to 14, I don't think we had a 3 to 14. I thought we had 2 3 to 17s and 2 3 to 12s.
12.
Yeah. All right. And so our last one that we got had 2 fish with sea lice. And out of how many did she catch?
15.
All right. So I'm going 1, 2, and then I'm going up to what number?
Directly in between 14 and 16.
Perfect. All right. So I'm going to try to use just a slightly different color just to put another dot here and another dot here. But this is our graph completed with the number of trials that we had. So remember, we had 5 trials. We had 2 trials that were 3 to 17, 2 trials that were 3 to 12, and 1 trial that was 2 to 15. So that is our completed graph. So make sure that you're writing that down in your math book, okay? Remember, you should be on, I believe, page 40 now. All right. So now we're going to look at number 2, and we're going to reinforce what we learned today. All right. So, Asia, will you read number 2 for us, please?
Suppose you took a survey in your homeroom class. You believe You believe your homeroom classmates share the same interests as the rest of the school. Also, you believe your homeroom is the average size of the classes in your schools. Here are the results of the survey.
All right, will you read the results for us?
Are you a male or female below? 14 male, 18 females. What are your favorite school sports results? 9 soccer, 16 football, 17 basketball, 14 baseball.
Not 14. Hold up, not 14. It said 6 football. Yeah, there you go.
6 other. What is your favorite technology? 8 DVD players, 12 music players, 12 video games, 10 video games to others. Where do you like to hang out? 3 library, 15 mall, 11 friends house, 3 my house. What's your favorite extra room? 13 skateboard, 1 snowboard, 5 surfs, 10
Motocross?
motocross, 3 BMX. Do I read 8?
Yes, ma'am, please.
Suppose you are 512 students in your class. Predict the results of the survey. If you gave it to every student in your class, explain how you found your prediction.
Great job. All right, so we're going to take A and we're going to do the exact same thing that we did for our beginning exercise. And we're going to use those same steps to figure out about how many in the whole school like the same things or are male or female. Okay, so we're going to start with our males. So if you look at this, there were how many males in that classroom?
14.
There were 14 males. And how many students are there in total? How would you find out how many students there are in total?
512.
That's how many students there are in total, but what about in the classroom? How could we figure out how many are in the classroom?
You would add 14 plus 18.
Good.
I got 32.
You are 100% correct. Good job. All right. So we get 32. And so you'll notice that we've set up a proportion just like we did a while ago. So what would I do to determine the scale factor so that I can figure out about how many students are in the entire school that are males? What would I have to do?
512 divided by 32.
Good deal. So we're going to do 512 divided by 32. So you can take your calculator, or you could take your cell phone's calculator, or you can do it by hand. But we need to see how many times 32 goes into 512. So to put that in our calculator, we would do 512 divided by 32, and then we would hit the equal sign. So what do we get?
16.
Good job, Talia. So we get 16. So this 16 is our what?
Total.
16 right here is the number. Good job, Kalia. And who can tell me what a scale factor does?
You multiply by the original number.
Correct. And that's either going to enlarge or reduce our figure. In this case, this is larger than 1, so that means that we're going to be doing what?
Enlarging.
Good job. We're going to enlarge. So we're going to take 14 and multiply it by our scale factor, and that'll tell us how many males there are in our school, or that will predict it. Good job. So X is 224. And we're going to put this information right under here. All right, so we got 224 males. How could we figure out how many females there are? Would we have to do all this work again?
Well.
Would you subtract 512 minus 224?
That's one way we could do it. So if we take 512 and subtract 224, we have 12. That would be 10. That'd be 4. What's 12 minus 4?
8.
Good. What's 10 minus 2?
8.
What's 4 minus 2?
2.
So how many females do we have?
288.
Good. All right. Does someone else know a different way we could have found the number of females? Could we have used our scale factor to find the number of females?
Could you multiply the number of females by your scale factor?
You are 100% correct, Rachel. Great job. So if we do 18 times 16, and we put that in our calculator, 18 times 16, what do we get? Good job. Is this the same answer as that?
Yes.
All right, so there was more than one way to find that answer, right? Great job. All right, so we're going to take what we found, what we've learned, and I'm going to allow you to find the answers to B, C, D, and E. All right, so I'm going to give you, there are 4 in that one, 4 in that one, 4 in that one. So let's see. I'm going to give you about 6 minutes to see how many you can get accomplished, okay? And then we're going to check our work. So right now, I want you working on questions B through E, all right? And if you have a question, you're more than welcome to chat it in the chat box, or you can raise your hand and I will help you any way that I can, all right? So I'm going to put 8 minutes on the board and I want you to do that now, all right? So remember, we're working on questions B through E, and you're trying to determine or predict the amount in the entire school for each one of these. So go ahead and start on that now.
Mr. Martin,
Yes, ma'am.
I don't really understand what we're supposed to solve because there's not really like a direct question for it.
Okay, so just like what we did before, all we're going to do is we are going to take each one of these. Say, for instance, this first one's 9 soccer players are what they surveyed in their classroom, and 9 people like soccer out of 32. So, since 9 people out of 32 like soccer, we know that our scale factor is 16. So, in other words, we know that 16 times the amount of inside of that classroom is how much it would be in the entire school that possibly likes that same sport, because that's our prediction based off of the results we got out of our classroom. So that means that we need to take our 9 people that like soccer, and we take 9 and we multiply it by our scale factor, and this will determine our prediction for how many people in the entire school like soccer. So we know that if we take 16 and multiply it by 9, 9 times 6 is what?
144.
Okay, well, you went on and gave me the whole thing, but 9 times 6 is 54. All right, and 9 times 1 is 9, and 9 plus 5 is what? 14. So we get 144 for our soccer players. So we're going to go through and check our results. Angel, was that helpful?
Yes, sir.
All right. So we know that our 9 soccer players ends up being 144 soccer players based off of what we just did. So what about our 6 football players? How would we determine that? What would we need to do?
Multiply by our scale factor, so 6 times 16.
All right. So what is 6 times 16?
96.
All right. You are 100% correct. So we get 96 for our football players. All right. What about 7 basketball players? How would we determine what that would be, Akira?
I'm still confused on it though.
All right. So we just worked through it. And go ahead, Angel.
Wouldn't that be like 112?
Which one?
The basketball player.
All right. So how would you find your answer? What would you do?
We would multiply 7 by 16.
Correct. All right. And what do we get when we do 16 times 7? 6 times 7 is 40.
2.
And 7 times 1 is?
7.
7 plus 4 is?
11.
So we get 112. All right. So Akira said she didn't really understand it. So Akira, I want you to try the next one for 4 baseball players. How would you predict how many people would like baseball out of the entire school? What would you have to do?
Divide.
All right. What have we, Akira, what have we done this entire lesson? What did we do at the beginning of number 2? What did we do?
Multiply.
We did. We multiplied. Why are we multiplying though?
So we can see how many. I don't really know.
Keep going with what you're thinking, because you're on the right lines, but you're not letting yourself speak how you think. So speak to me what you're thinking in your mind.
That we got multiply how many times until we get to the amount of how many people are in the school or something.
Correct. All right. And in this case, we know that there are 32 students in all. Okay. Since there's 32 students in the classroom, they took a survey. And so 9 of the people said they like soccer. 6 of them said they like football. 7 said they like basketball. 4 said they like baseball. And 6 of them said they like cheerleading and stuff. Okay. So out of these, what we did was we determined our scale factor. So we would see how much we needed to enlarge each amount by in order to figure out a prediction for the entire school. So to get a prediction for the entire school, what we do is we take 32 times 16 to get 512. So that means that everything in here has to be multiplied by 16 in order to find out our prediction. So in this case, our 4 baseball players would need to be multiplied by what?
16.
Correct. So we're going to do 4 times 16. And that will tell us how many people like baseball.
64.
You're 100% correct.
So 16 multiplied by the thing would be the answer.
Yes, you're 100% right.
Okay.
All right. Angel S., tell me what you got for the 6 other.
took 6 and multiplied it by 16.
Okay, and what's 6 times 16?
96.
Good job. I like the song you're listening to. All right. C. Angel V. My DVD players. What would you do to find that answer?
You would do 3 times 16.
All right, you're talking about the library, but yeah, that's right. 3 times 16 gives us what?
3 times 16 equals 48.
Good job. All right, Asia, what'd you get for the 8 DVD players?
I got 128.
Okay. What'd you get for 12? For the music. How many would you predict? And how would you get your answer?
I got 192 because 12 times 16 is 192.
Good job. All right. What about the 10?
Can I excuse myself real quick?
Sure. What about the 10 video games, Hagen?
I got 160 because 10 times 16 is 160.
Good job. All right. Let's see what else, who else we can call on real quick. My screen's messing up. All right. Anyways, who else can help us out? Levi, tell us what you got for the 2 others. Good job, because 2 times 16.
Because I did 16 times 2 because the skill factor is 16.
Perfect job, man. So, Levi, while I have you here, tell us how we would find all of the ones for D and E. What would we have to do? In each case, what do we have to do?
Multiply 16. Multiply by 16. Multiply the original number by 16.
And why do we have to do that?
Because that's the scale factor.
Perfect. All right. And the scale factor is telling us how much we need to enlarge our classroom amount by in order to get the amount for the entire school. All right. So, in closing to our lesson today, at the beginning of class, I gave you an opening question that said, suppose we know that there are 200 objects in the bowl, and we know that they're marbles, okay? So when we find out how many marbles there are, we need to take the marbles and we need to pull out the marbles 20 times. And every time that we pull out the marbles, we're going to record how many red marbles we get out of the total number. So is it a possible way that we could predict how many red marbles are in that bowl based off of those? Would we be able to predict how many there are in the entire bowl based off of those 20 pools?
Yes.
Yes. What could we do to make a prediction? What did we do for finding how many fish were sick in the pond? We found something. What did we find? Started with an A.
Average.
That's right. We found the average. So we could find the average amount of red marbles, right? And then we could make a prediction based on how many that there are in the bowl. All right. So tell me this. This is our higher order thinking STEM question. If you know the likelihood that something will occur, how can you find the likelihood that it won't occur? If you know the likelihood that something will occur, how could you find the likelihood that it will not occur? So say we do something a total of 10 times, and we know that the likelihood that it will occur, what we want to happen, is 4. How would we determine the likelihood that it would not occur?
Subtract.
Correct. What would we do?
10 minus 4.
100% correct. All right. So that is the conclusion of our class today. Remember that our homework tonight is to complete questions 16 through 21 in our more practice in our Agile Mind computer. All right. Make sure that you do that tonight. Yesterday's homework was to complete questions 11 through 15. If you haven't done that, you need to make sure you catch up. And I will see y'all tomorrow.